Hello guys, good evening. I welcome you all on Unacademy, India's largest learning platform. Today we are going to revise this respiratory system. Before starting the topic, a little bit of introduction. Myself, Dr. Nidhi, I am physiology educator at Unacademy. So this is our Telegram page. You can follow me us on this page, that is Let's Crack Neat PG, so that you will get link of each and every classes out here. This is my page on Unacademy, unacademy.com/KGMC. Follow me out there so that you will get notification of every class and you won't miss a single class. This is the code Dr. Nidhi. If you want to join any so you can use this referral code to get additional 10% off. I have taken many plus classes, many special classes, so anytime you can join and revise the topic. Now coming to this calendar, this is the upcoming test calendar, so do join if you are serious about your examination, because test देने से क्या होता है, आप अपनी preparation को analyze करते हो, and at any point of time you can analyze your preparation from this test and you can accordingly plan for your upcoming exam. Coming to this next, that is we are going to have this all India mock test. If you are targeting this NEET PG 2022, do enroll yourself for all India mock test. For enrollment, to use the code, that is Dr. Nidhi. This mock test is going to happen on 27th March 9 a.m. Do remember the date and timing. Coming to the next, that we are launching this previous year question bank, that is on 23rd March. A dedicated session for previous year questions होंगे. NEET PG examinations like NEET PG, INSCT, FMG will be covered. 3 past year papers solve कराए जाएंगे and that is going to give you the quick revision. We are launching this MBBS professional first also. ठीक है, योर पार्ट टूवर्ड क्रैकिंग MBBS एंड द नेक्स्ट, इसमें क्या होगा, डेप्थ वाइज आपका सारा टॉपिक कवर कराया जाएगा. इंटीग्रेटेड सेशंस होंगे, आंसर राइटिंग सेशंस होंगे, सब्जेक्ट वाइज टेस्ट होंगे हर सैटरडे को, एंड उसका रिवीजन और उसका डिस्कशन जो होगा वो होगा मंडे को. सब्जेक्ट वाइज टेस्ट भी होगा, लाइव इंटरेक्टिव क्लासेस होंगे, डाउट क्लियरिंग सेशन होंगे, रिकॉर्डेड सेशन भी अवेलेबल होगा. PDF notes you can also download. So if you are in the first prop, you can join this our new launching, that is MBBS Prof 1. Coming to our subscription, we have two type of subscription: plus subscription as well as iconic subscription. First, coming to the plus subscription, when you take plus subscription, you are able to access both live and recorded session. किसी वजह से आपका session miss हो जाता है तो आप recorded version देख सकते हो. You have an opportunity to learn from India's top educator for the medical examination. We always conduct this live test and live quizzes. From that you can analyze your preparation at any point of time. You have a flexibility, you can study on the device of your choice. आपका फ़ोन हमेशा आपके साथ होता है, आप फ़ोन से एक्सेस कर सकते हो. If you want to go for the bigger screen, you can go for the bigger screen. We have a question bank which consists of 25,000 plus question, high yield question है, clinical based question and with explanation है. So this is going to be very beneficial for all of you. Now coming to the iconic subscription, where you get access of India's two best platform, that is Unacademy and the Prep Ladder. So you are going to get all the plus benefit of Unacademy, like I said, live classes, recorded classes, question bank, live tests and live quizzes. Along with that, you get access for the Prep Ladder. In this, you can access the clinical and integrated essential of Prep Ladder, video lecture from Dream Team, Question Bank 3.0, rapid revision and snapshot, and you will also be provided with their treasure and dream notes. So if you want to access the Prep Ladder also, go for the iconic subscription. They are our FMZ December 2021 toppers. Special class feature की बात करेंगे तो you all know a special class is always and always live. Live classes का benefit क्या होता है कि आप अपने एजुकेटर से interact कर सकते हो, अपने डाउट को लाइव सेशन में क्लियर कर सकते हो. पोल्स के फीचर होते हैं जिससे क्लास काफ़ी इंगेजिंग होता है. रेज हैंड फीचर्स देयर. नाउ यू कैन टॉक टू एजुकेटर इन द लाइव सेशन एंड क्लियर योर डाउट. अगर किसी एजुकेटर को फॉलो करते हैं तो उनके क्लास से प्रायर आपको नोटिफिकेशन. After the lecture, you can download the PDF and provides it anytime, anywhere. We are going to start this high yield theory revision batch. If you are targeting this NEET PG 2022, we are going to have this high yield theory revision batch, जो कि 30th March से start होगा and that will last till 15th May. यानी टोटल 1.5 मंथ की कोर्स होगी, 140 आवर्स ऑफ रिवीजन होंगे, रिकॉर्डेड क्लासेस होंगे, 2 ग्रैंड टेस्ट विल बी देयर, ठीक है, क्वेश्चन बैंक्स मिलेंगे आपको, इंटरैक्टिव लाइव सेशंस होंगे, पीडीएफ यू कैन डाउनलोड. So these are the features you will get in this revision batch. We are going to start this high yield revision and MCQ batch for FMG 2022. So you can join this one also. इसकी भी ड्यूरेशन रहेगी जो वो होगी 2 मंथ्स की, 30th मार्च से ये स्टार्ट होगा एंड दैट विल लास्ट टिल 30th May. This is the fee structure plus subscription की fee structure is somewhat like this. Iconic subscription fee structure is somewhat like this. Light subscription which is a newly added one जहाँ पे आप you can access all the tests, live tests जो भी होंगे हमारे grand test, subject wise test, उसको आप join कर सकते हो. इसकी सब्सक्रिप्शन फी इज ऑल्सो वेरी इकोनॉमिकल. 2 मंथ की फीस है 2160, 3 मंथ फीस इज 2700, 6 मंथ फी इज 4860, 9 मंथ फी इज 5400. 1 ईयर की फीस की बात करेंगे तो इट इज 5940 ओनली. तो बहुत ही इकोनॉमिकल प्राइस है. तो अपने रिक्वायरमेंट के हिसाब से यू कैन परचेज योर सब्सक्रिप्शन. Coming to the revision, today we are going to revise the respiratory system. First topic which we are going to revise is structural component of lung. So to understand this structural component of lung, we have to first understand this generation of lung airway. This is defined by Weibel's. So this model is important, Weibel's model. According to this model, our airway is divided into 23 generation. इसमें जो first 16 generation है, that is conducting airway or dead space. ठीक है. Last 7 generation क्या है? Last 7 generation is exchange airway, alveolar airway or respiratory airway. Why the first 16 generation is known as dead space? Because this is not involved in gaseous exchange. So that's why it is only the conducting pathway. So that's why it is known as conducting airway or dead space. Last 7 generation में क्या होता है? Gaseous exchange occurs. So that's why it is known as exchange airway, alveolar airway or respiratory airway. This is the diagram. This conducting airway starts from trachea and it ends with the terminal bronchial. And this respiratory airway starts from this respiratory bronchioles and it ends with the alveolar sac. So you can say this trachea is the largest one and alveolar sac is the smallest one, and the terminal bronchiole mark the transition between these two, conducting airway and respiratory airway. So all these points are very important. हमारा फर्स्ट 16 जनरेशन क्या है? कंडक्टिंग एयरवे, स्टार्ट्स फ्रॉम ट्रैकिया, इट एंड्स विद द टर्मिनल ब्रोंक्यूल. लास्ट 7 जनरेशन क्या है? रेस्पिरेटरी एयरवे, दैट स्टार्ट विद द रेस्पिरेटरी ब्रोंक्यूल एंड एंड विद द alveolar sac. So now coming to the first, that is conducting airway. इसको अब हम डिटेल में देखेंगे. दिस कंडक्टिंग एयरवे की एपिथेलियम की अगर बात करें तो its epithelium is pseudostratified ciliated columnar epithelium. Pseudostratified ciliated columnar epithelium है, and it consists of 2 stem cells, that is basal cell and clara cell. So these 2 cells are important to remember. Epithelium कैसा है? Pseudostratified ciliated columnar epithelium. So the cilia is important. So see, this is the diagram. कैसा epithelium है? Pseudostratified. Cilia present है, ciliated, column like cells है, columnar epithelium cells. 2 हमारा stem cell out here are basal cell and the clara cell. They both act like a stem cell. Is this clear with everybody? Moving further to the cilia. What is the cilia? Cilia are the finger-like projection on the lining cell and they are capable of movement. Why the cilia is capable of movement? Because of presence of protein that is called as dynein. Due to presence of this dynein, हमारा cilia कैसा होता है? Motile होता है. So what is the function of this cilia? Ciliary movement की वजह से क्या होता है? हमारा जो sputum है वो nasopharynx से expelled होता है. So this is a function. Now coming to the metachronism. What is the metachronism? हमारा जो cilia है एक synchronized way में सारी cilia move करती है and that phenomena is known as metachronism. और this cilia, अब बात करेंगे next function of the cilia. First function is expulsion of sputum. Second function is during embryological development the cilia is responsible for rotation of internal organ. Means our internal organ is basically different position पे होता है initially, but after this ciliary movement क्या होगा, हमारा cilia की movement की वजह से our internal organ excuse me, our ciliary movement causes rotation of this internal organ and internal organ अपने actual position में आता है. So this gyne is important for the ciliary movement. Beside that, it is also important for the movement of sperm as well as fallopian tubule. Now coming to the clinical aspect, that is absence of this gyne. So absence of dynein हो जाएगा तो क्या होगा, हमारा ciliary movement is stop, sperm movement नहीं होगा, fallopian tube movement नहीं होगा. So it is going to lead the immotile cilia syndrome, and out of this the most important one is this carcinogenous syndrome. This consists of a triad. कौन कौन से triad होते हैं? Sinusitis, bronchitis and the situs invertus or sinus invertus. ठीक है, क्या क्या ट्राइड मिलेंगे? डू रिमेम्बर साइनोसाइटिस बिकॉज स्पुटम इज नॉट क्लियर. ठीक है, अगर साइनोसाइटिस से अगर साइनोसाइटिस को अगर ट्रीट नहीं करते हैं तो इट कैन लीड टू द ब्रोंकिटाइटिस. ठीक है, एंड इंटरनल ऑर्गन डिफेक्टिव रोटेशन हो सकता है, तो दैट इज नोन एज साइटस इनवर्टस. ठीक है, प्लस इमोटाइल सीलिया सिंड्रोम, कार्टाजेनस सिंड्रोम में ट्राइड के साथ साथ हमें क्या मिलेगा? Associated infertility will also be seen because dynein absent है. Dynein absent है तो sperm movement भी नहीं है और fallopian tubule movement भी नहीं है. So both male and female दोनों ही में हमें क्या मिलेगा? Infertility will be seen. In male, the immotile sperm will be seen and that is known as asthenospermia. Immotile sperm due to absence of this dynein is known as asthenospermia. Is this clear with everybody? So this is about the carcinogenous syndrome. Do reply first. Is this clear? So moving further to the next disorder related to our cilia is cystic fibrosis. क्या सिचुएशन है? यहाँ पे cilia is normal, dynein is present, but cilia cannot propel this sputum because out here the sputum are thick. Why the sputum are thick? Because out here we have this cystic fibrosis transmembrane regulator gene defect, CFTR gene defect. Cystic fibrosis transmembrane regulator gene defect की वजह से क्या होगा? Sputum is thick and that is going to cause this cystic fibrosis. So what we are going to see in this situation, this cystic fibrosis transmembrane regulator gene क्या करता है? It mediate the opening of chloride channel. Chloride mix with the sputum and normally sputum are thin. But due to mutation of this gene, what happened? There will be defective chloride opening, and that's why that is leading to the thick sputum. So that's why अगर treatment line पे अगर हम जाते हैं तो we will give this calcium channel opener. ठीक है, सॉरी chloride channel opener, ताकि chloride ion हमारा influx start हो जाए and that is going to mix with the sputum and that is going to cause thinning of sputum. So we use this EVA catheter in the cystic fibrosis. Is this clear? सिस्टिक फाइब्रोसिस क्यों है? सिस्टिक फाइब्रोसिस ट्रांस मेम्ब्रेन रेगुलेटर जीन डिफेक्ट की वजह से. एंड व्हाट डज दिस सिस्टिक फाइब्रोसिस ट्रांस मेम्ब्रेन रेगुलेटर जीन डू? इट causes opening of this chloride channel, chloride efflux start, and that chloride mix with the sputum, and that causes thinning of sputum. Is this clear? Moving further to the next unique feature of our conducting airway is presence of smooth muscle lining in our conducting airway. And this smooth muscle lining is maximum in terminal bronchioles. Do you remember this point is important? So moving further, what happened during normal condition क्या होगा अगर due to exposure of cold and dust, this conducting airway smooth muscle undergo contraction, and that is going to lead bronchoconstriction, जिसकी वजह से क्या होगा air flow decrease होगा, air flow resistance is going to increase. But in exaggerated conditions क्या होगा अगर bronchoconstriction is more in our conducting airway, that is going to lead the bronchial asthma. So इसलिए हम इस सिचुएशन में we give the treatment by bronchodilators. ठीक है? Is this clear? So agent अब बात कर लेते हैं. Now coming to the agent that causes this bronchoconstriction are our parasympathetic nervous system activation. That activation is going to lead formation of acetylcholine, and so this acetylcholine is going to cause the bronchoconstriction. So that's why when we give, now coming to the treatment line, acetylcholine blocker like ipratropium bromide, they are going to cause relaxation, they are inhibiting the constriction of bronchioles. So that's why it is used in the treatment of asthma. Acetylcholine blocker like ipratropium bromide is used in the treatment of asthma. Synthetic अगर acetylcholine की बात करेंगे like methacholine, तो most common side effect यहाँ पे क्या मिलेगा हमें? Bronchoconstriction, because it is going to act like acetylcholine, and acetylcholine क्या करेगा? Acetylcholine is going to cause bronchoconstriction. Is this clear? Next is the histamine. This histamine also causes this bronchoconstriction. Leukotriene. This leukotriene is also going to cause the bronchoconstriction, and this leukotriene is the most potent bronchoconstriction. So that's why the leukotriene blockers like montelukast are very effective in treatment of bronchial asthma. Is this clear, everybody? So agents that causes bronchoconstriction are our parasympathetic nervous system, our vagal stimulation, our acetylcholine, our our leukotrienes, our histamine, they all causes bronchoconstriction. Now coming to the agent that causes bronchodilation. In this we have the sympathetic nervous system that act via beta 2 receptor to cause this bronchodilation. So that's why beta 2 agonists like salbutamol, it is going to cause bronchodilation. So that's why it is used in the treatment of asthma. Next is the nitric oxide. It is a universal dilator. So out here also it is going to dilate our bronchioles. Next is the vasoactive intestinal peptide. This is also going to cause the bronchodilation. Now after the conducting airway, moving to the alveolar airway. Our alveolar airway is also known as exchange airway because यहीं पे हमारा gaseous exchange होता है. And it is also known as respiratory airway. इसमें जो हमारा आता है वीवल मॉडल की अगर बात करें तो लास्ट 7 जनरेशन ऑफ वीवल मॉडल corresponds to our alveolar airway, and this alveolar airway is responsible for gaseous exchange, already discussed. So that's why it is known as exchange airway. So this alveolar airway consists of two type of pneumocyte, type 1 and type 2 pneumocyte. This type 2 pneumocyte is responsible for production of surfactant. So this point is important from the exam point of view. Which type of pneumocyte is going to form the surfactant? Type 2 pneumocyte. And this type 2 pneumocyte also acts as a stem cell for alveolar airway. Conducting airway के लिए कौन-कौन से हमारे stem cells होते हैं? Anybody? Conducting airway में we have which type of stem cells? Do reply fast. Stem cell in a conducting airway. Basal cell and Clara cell are the stem cell in our conducting airway, while in our alveolar airway we have this type 2 pneumocyte acting like a stem cell. So this is the diagram. This is the type 1 pneumocyte. This is the type 2 pneumocyte. Type 1 pneumocyte is 95% of alveolar surface is covered by this type 1 pneumocyte. They are squamous, they are extremely thin. They are involved in gaseous exchange. While type 2 pneumocyte is roughly cuboidal and it is granular in nature and covers only 5% of alveolar surface, and they are going to secrete this pulmonary surfactant. Take clear? Moving further to the surfactant structure, first coming to the structure part. This surfactant consists of lipid and the protein molecule. Lipid, in this we have major lipid and the minor lipid. Major lipid is lecithin, dipalmitoyl phosphatidylcholine. Do remember this name because काफी बार एग्जाम में आता है. The major lipid in our surfactant is lecithin, or you can say dipalmitoyl phosphatidylcholine is the major lipid in our surfactant, and the minor lipid in our surfactant is sphingomyelin. And protein की बात करेंगे. Protein in our lipid is known as surfactant protein, and we have 4 type of surfactant protein. Surfactant protein A, B, C and D. Among this A and D surfactant protein A and D is responsible for lung immunity. Is this clear with everybody? So moving further, what is the significance of this lipid? Lecithin upon sphingomyelin ratio more than or equal to 1 equal to 2 is signifying this adequate fetal lung maturity. ठीक है? And when amniotic fluid is taken in a test tube and it is shaken, so if bubble appear, then it is indication of the presence of surfactant lipid. ठीक है? This test is known as shake test, bubble test or Clement test, and this is showing our adequate fetal lung maturity. So for checking this adequate fetal lung maturity, we can do one first thing, that is lecithin upon a sphingomyelin ratio. Second thing which we can do is shake test, bubble test or Clement test. Is this clear with everyone? Moving further to the surfactant production appearance. Surfactant production starts at 28 to 32 week of gestational period. And now coming to the most important part, that is what is the function of the surfactant. Normally the alveolar surface is lined up with the water molecule. Suppose this is our alveoli. This alveoli in a normal situation is lined up with the water molecule, and this water molecule exert the surface tension towards the center, and due to that क्या होगा, हमारा lung has tendency to collapse. So this has tendency to collapse the alveoli. So due to that क्या होगा, हमारा surfactant क्या करता है, water molecule को break करता है, and that is going to decrease the surface tension. ठीक है? तो क्या क्या फंक्शन हो गया, surface tension decrease करता है, it prevent the collapse of alveoli, so it is going to ensure the stability of alveoli. Is this clear with everybody? Now Laplace law क्या कहता है, tension is equal to pressure into radius. Alveoli कैसा है, sphere है, so out here twice the tension is equal to pressure into radius. So what does surfactant do? Surfactant हमारा surface tension को reduce करता है, and tension reduce होगा, see, तो radius क्या हो जाएगा, increase, because tension is equal to pressure into radius. So tension is directly proportional to the radius. So tension, surface tension reduce होगा, sorry, so radius is going to increase. It is going to surface tension reduce होगा, हमारा जो pressure होगा वो increase होगा. So that's why radius of alveoli is going to increase. So surface area is going to increase. So the collapsing pressure decreases. Is this clear with everybody? अब हम बात करेंगे surfactant are stored in type 2 pneumocyte in the form of lamellar bodies. So do remember this point. Storage किस form में होता है? Storage होता है हमारा lamellar body के form में, and that's why lamellar body count is important because इससे हम test कर सकते हैं fetal lung maturity. So clear हुआ? Fetal lung maturity के लिए we can do first thing, that is less than upon a sphingomyelin ratio greater than or equal to 2. Second thing we can do is bubble test, Clement test. Third thing which we can do is lamellar body count. Is this clear? Moving to the further to the regulation of surfactant production. So there are some factors that is going to increase the surfactant production. There are some factors that is going to decrease the surfactant production. First, coming to the factor that increases surfactants are, first is steroids. Our glucocorticoids, यानी our cortisol is going to increase the surfactant production. So that's why in preterms baby में क्या होगा? Immature lungs होंगे, and that's why in preterm baby we give this dexamethasone and betamethasone to increase the surfactant production in the baby. ठीक है? Next is the thyroid hormone. Thyroid hormone T3 and T4 also increases the surfactant production. Next, the factor that decreases surfactant are always and always pathology. ठीक है? कैसे pathological है? Because अगर gestational diabetes mellitus mother positive आई तो उस केस में इन्फेंट में क्या होगा? सर्फेक्टेंट का प्रोडक्शन डिक्रीज हो जाता है, एंड दैट इज गोइंग टू लीड दिस हाइलीन मेम्ब्रेन डिजीज. एंड हाइलीन मेम्ब्रेन डिजीज यानी ये कैसा हो गया? पैथोलॉजिकल कंडीशन हो गया. तो सर्फेक्टेंट का प्रोडक्शन हमेशा पैथोलॉजिकली डिक्रीज होता है. नॉर्मल सिचुएशन में ये डिक्रीज नहीं हो सकता. इज दिस क्लियर? नाउ अगर हाइलीन मेम्ब्रेन डिजीज है इन्फेंट में तो ट्रीटमेंट की अगर बात करेंगे तो वी गिव दिस ड्रग फॉर्म ऑफ सर्फेक्टेंट लाइक लुसिनैक्टिन एंड बेरैक्टिन. Clear everyone? So factor that increases surfactant are, कौन से फैक्टर हमारे सर्फेक्टेंट प्रोडक्शन को इंक्रीज करता है? आवर कॉर्टिसोल, our dexamethasone, betamethasone is going to increase the cortisol production. Our thyroid hormone T3 and T4 is going to increase the surfactant production. Factor that decreases surfactant is always and always pathological. Gestational diabetic mellitus अगर मदर है तो इन्फेंट में क्या होगा? हाइलीन मेम्ब्रेन डिजीज होने के काफी हाई चांस होते हैं, एंड इन दैट सिचुएशन वी गिव द ड्रग फॉर्म ऑफ सर्फेक्टेंट लाइक लुसिनैक्टिन और बेरैक्टिन. Moving further to the mechanism of breathing. To understand that, first of all, coming to the Boyle's law, what does Boyle's law state? It states that pressure is inversely proportional to the volume. If volume increases, pressure is going to decrease. अब हम आ जाते हैं अपने respiratory physiology पे. तो volume out here is, we are talking about the tidal volume of 500 ml, and pressure की अगर बात करेंगे तो we are talking out here for the three pressure, that is intrapleural pressure, alveolar pressure और transpulmonary pressure. So three pressure के बारे में हम डिस्कस करेंगे, intrapleural pressure, alveolar pressure और transpulmonary pressure. First coming to the intrapleural pressure. As the name suggests, intrapleural means between the two pleural layers. The pressure between the two pleural is going to cause us intrapleural pressure. ठीक है? तो resting condition में intrapleural pressure negative होता है. Why is it negative? Because pleura क्या है? Pleura हमारा एक साइड से lung से attach है and एक साइड से chest wall से attach है. ठीक है? Chest wall की tendency है to move outward, lung की tendency है to collapse. सो बिटवीन दीज टू अपोजिट फोर्सेस क्या होगा, प्लूरा स्ट्रेच्ड होगा एंड ड्यू टू स्ट्रेचिंग क्या होगा, हमारा जो वैक्यूम लाइक स्टेट बिटवीन द टू प्लूरल एयर विल बी क्रिएटेड एंड दैट्स व्हाई इंट्रा प्लूरल प्रेशर कैसा होता है, it is always and always negative. So see, this is the diagram. Let me change the color. ये हमारा लंग हो गई, ये हमारा लंग वॉल हो गया, ये हमारा चेस्ट वॉल हो गया एंड बिटवीन दीज टू वी हैव दिस प्लूरल स्पेस जहाँ पे क्या है, वैक्यूम लाइक स्टेट क्रिएट होगा एंड दैट इज गोइंग टू कॉज दिस इंट्रा प्लूरल प्रेशर नेगेटिव. सो व्हाट हैपन ड्यूरिंग इंस्पिरेशन, अगर बात करेंगे तो ड्यूरिंग एन इंस्पिरेशन वॉल्यूम ऑफ द लंग इज गोइंग टू इंक्रीज एंड वॉल्यूम इंक्रीज होगा तो फ्रॉम द बॉयल्स लॉ volume is in pressure is inversely proportional to the volume is increasing so pressure is going to decrease. So intrapleural pressure from minus 2.5 decreases to minus 6 mm of Hg means हमारा intrapleural pressure क्या हो गया, it become more negative during inspiration. अगर expiration की बात करते हैं तो during expiration क्या होगा, volume of lung is going to decrease so intrapleural pressure क्या होगा, increase. So it increases from minus 6 to minus 2.5 mm of Hg. Is this clear everybody? Intrapleural pressure कैसे change हो रहा है, resting condition में it is negative, it is minus 2.5 mm of Hg. Inspiration में volume increase होगा, pressure is again going to decrease and from minus 2.5 ये decrease होके minus 6 mm of Hg पे reach कर जाएगा. During expiration क्या होगा, volume in the lung it is going to decrease and intrapleural pressure increase होगा and that's why from minus 6 से ये reach होता है minus 2.5 mm of Hg. Is this clear everyone? Do reply fast. Is this clear? Everybody, moving further. Now coming to the alveolar pressure. Resting condition में alveolar pressure is 0. Inspiration में again क्या होगा, volume increase होगा so pressure is going to decrease from 0 it reaches to minus 1 mm of Hg. ठीक है, at the end of inspiration alveolar pressure again becomes 0. अब expiration start होगा तो volume decrease होगा तो pressure is going to increase from 0 it increases to plus 1 mm of Hg and at the end of expiration हमारा again alveolar pressure क्या हो जाएगा, 0. So see this is the curve. Inspiration में क्या होगा, volume is going to increase so pressure is going to decrease. This is the curve for intra-alveolar pressure ना, तो at the resting condition कितना होता है, 0. ठीक है, at the inspiration के बाद क्या होगा, it become more negative, it become minus 1 mm of Hg and at the end of inspiration क्या होगा, again becomes 0. ठीक है, एंड एक्सपिरेशन के वक्त क्या होगा, वॉल्यूम इज गोइंग टू डिक्रीज, सो प्रेशर इज गोइंग टू, एक्सपिरेशन क्या होगा, वॉल्यूम इज गोइंग टू डिक्रीज, सो प्रेशर क्या होगा, प्रेशर इज गोइंग टू इंक्रीज. So 0 से it comes to plus 1 mm of Hg, and at the end of expiration it again reaches to 0. This is about alveolar pressure. Clear? Moving further to the next, that is transpulmonary pressure. It is a derived pressure. It is equal to alveolar pressure minus pleural pressure, and they are responsible for the opening of muscle. ठीक है. रेस्टिंग कंडीशन में हमारा एल्वेओलर प्रेशर कितना होता है, 0. रेस्टिंग कंडीशन में हमारा इंट्राप्लूरल प्रेशर कितना होता है, -2.5 mm. So at the resting condition the transpulmonary pressure is 2.5 mm of Hg. Moving to the summary, pressure volume changes during breathing की बात करेंगे. तो during inspiration क्या हो रहा है, volume is going to increase, pressure is going to decrease. So intrapleural pressure decreases, alveolar pressure decreases. Intrapleural pressure become -6 mm of Hg, alveolar pressure become -1 mm of Hg. Expiration की बात करेंगे तो volume is going to decrease, so pressure is going to increase. So intrapleural pressure is going to increase and it reaches to -2.5 mm of Hg. ठीक है. And alveolar pressure also going to increase, so it reaches to +1 mm of Hg. Is this clear with everybody? To reply fast, is this clear? So moving further, this is the diagram. So during inspiration volume is going to increase, so pressure is going to decrease, so alveolar pressure also decreases, intrapleural pressure also decreases, and during expiration volume is going to decrease, so pressure is going to increase, so alveolar pressure increases, intrapleural pressure also increases. So moving further to the muscles of breathing. अगर नॉर्मल क्वाइट ब्रीदिंग की बात करेंगे तो हमारा इंस्पिरेशन कैसा है, एक्टिव प्रोसेस है, एंड एक्सपिरेशन इज पैसिव प्रोसेस. सो इंस्पिरेशन में द मोस्ट important one is the diaphragm. Diaphragm play an important role in our inspiration. Accessory muscles are also there that are involved in inspiration is sternocleidomastoid, sclerae muscle, and external intercostal muscle. These three muscles are accessory muscle for the inspiration. So see, this is the diagram. Go via the recoil of lung and the rib cage. Active expiration are due to internal intercostal, rectus abdominis, obliquus, and transverse abdominis muscle. These are required for active expiration. Is this clear? Moving further, same thing is written out here. Expiration normally तो passive होता है. During exercise it involves internal intercostal, rectus abdominis, transverse abdominis. Now coming to the compliance. So what is the compliance? Compliance क्या होगा, हमारा इंस्पिरेशन के बाद एयर मूव्स टू आवर alveoli and the stretching of alveoli due to inspiration is the compliance. The stretching ability of alveoli or distension ability of alveoli is the compliance. Is this clear? What is compliance? Stretching of alveoli is compliance. Moving further, there are two forces that opposes this stretching of alveoli. First is the surface tension that is exerted by the water molecule. Second one is the elastic recoil, elastance or the elasticity. This also opposes the stretching of alveoli. So we can say this compliance is inversely proportional to the elastance and it is inversely proportional to the surface tension. सो इन एम्फाइसेमा अगर डिजीज की बात करते हैं तो लंग की इलास्टिसिटी क्या हो जाती है, डिक्रीज हो जाती है, एंड इलास्टिसिटी डिक्रीज होगी तो कॉम्प्लायंस क्या हो जाएगा, इंक्रीज हो जाएगा. सो वी कैन सी इन एम्फाइसेमा कॉम्प्लायंस इंक्रीजेस. सो अगर कॉम्प्लायंस इंक्रीज हो जाएगा तो स्ट्रेचिंग ऑफ एल्वेलाई विल बी मोर, एंड स्ट्रेचिंग ज्यादा होगी तो हमारे लंग में क्या होगा, ओवर डिस्टेंशन विल बी सीन, एंड ओवर डिस्टेंशन की वजह से हमारे लंग में हाइपर इन्फ्लेशन एरिया विल बी सीन. Is this clear? Moving further, in restrictive lung disorder अगर pulmonary fibrosis की बात करते हैं तो उस सिचुएशन में क्या है कि हमारा compliance decrease होता है. So do remember, in obstructive lung disease हमारा compliance increase होता है, in restrictive lung disorder compliance decreases. अगर नॉर्मल कॉम्प्लायंस ऑफ लंग की बात करते हैं, इट इज 200 ml पर सेंटीमीटर ऑफ वाटर. कॉम्प्लायंस को हम इस तरह भी कह सकते हैं, फॉर गिवन चेंज इन अ वॉल्यूम द प्रेशर, for given change in a pressure, the volume change in our alveoli, the volume change means stretching of our alveoli, that is compliance. So we can say compliance is for given change in a pressure, the volume change is compliance. Is this clear with everybody? So this is the normal compliance curve between the change in lung volume with the change in pressure. So this is the normal compliance curve. अब आ जाएंगे लो कॉम्प्लायंस कर्व और हाई कॉम्प्लायंस कर्व. एम्फाइसेमा में क्या होता है, टिश्यू की इलास्टिसिटी मोर होती है, देयर विल बी मोर स्ट्रेचिंग. सो सिचुएशन में फॉर गिवन चेंज इन अ प्रेशर द वॉल्यूम चेंज इज मोर. सो सी दिस इज द कर्व. फॉर गिवन चेंज इन अ प्रेशर द वॉल्यूम चेंज इज वेरी मोर. सो दैट्स व्हाई इट इज हाई कॉम्प्लायंस कर्व. और ये कब मिलेगा हमें, एम्फाइसेमा में मिलेगा. लो कॉम्प्लायंस कर्व कब मिलता है, जब for given change in a pressure the volume change is very low. So this is a compliance, कैसा compliance curve है, low compliance curve है, and this is seen in pulmonary fibrosis. Restrictive lung disorder में क्या होगा, compliance is less, and obstructive lung disorder में क्या होगा, compliance is more. Is this clear with everyone? Moving further, same thing is written out here. In restrictive lung disorder, lung will not distend on increasing pressure, so that's why we'll get this poor compliance and curve will comes down. Coming to the next type of compliance. So compliance हमारा दो तरह से हो सकता है, static compliance और the dynamic compliance. First coming to this static compliance. Compliance during the breath holding situation is the static compliance. ठीक है, and normal value जो अभी अपने बात की थी, normal compliance कितना होता है, 200 ml per centimeter of water. This is our static compliance. Next is the dynamic compliance. As the name suggests, it changes with the time. So it changes with the stage of breathing. एट द स्टार्ट ऑफ इंस्पिरेशन, देखो इसको एक्सप्लेन करते हैं. एट द स्टार्ट ऑफ इंस्पिरेशन एल्वेलाई क्या होती है, एल्वेलाई आर स्मॉल, एंड एल्वेलाई स्मॉल होगी तो सर्फेक्टेंट का डिस्ट्रीब्यूशन लोअर एरिया में होगा, तो सर्फेक्टेंट का कंसंट्रेशन क्या होगा, मोर होगा. तो सरफेस टेंशन यहाँ पे क्या होगा, ज्यादा रिड्यूस होगा, तो सरफेस टेंशन ओवरऑल क्या हो जाएगा, लो हो जाएगा. एंड वी ऑल नो कंप्लायंस इज इनवर्सली प्रोपोर्शनल टू द सरफेस टेंशन. So surface tension यहाँ पे less है smaller compliant में, so compliance is more. So at the start of inspiration compliance is more, at the end of inspiration क्या होगा, alveoli हो जाएगी large, surface tension is more. ठीक है सर, क्योंकि surfactant क्या हो जाएगा, higher area में distribute हो जाएगा, तो surface tension reduce कम होगा, surface tension overall क्या होगा, more. So compliance is less in this situation. Next is the derived compliance, that is specific compliance. Specific compliance क्या होता है, normal compliance upon FRC is going to this give this specific compliance. Is this clear with everybody? So we have static compliance, we have dynamic compliance, and we have this specific compliance. ठीक है, compliance curve और इसके related कुछ questions जो है वो हम next session में करेंगे. नेक्स्ट सेशन को यहीं से कंटिन्यू करेंगे. ठीक है, आज के सेशन में किसी को कोई डाउट, एनीबॉडी एनी क्वेरी टिल नाउ यू कैन आस्क इन द सेशन ओनली. होप यू ऑल लाइक द सेशन. इफ यू लाइक द सेशन डू लाइक एंड शेयर, दिस इज इंपॉर्टेंट. जितना लाइक और शेयर करोगे उतनी क्लास इंटरैक्टिव होती है, सो डू शेयर एवरीबॉडी. अगर चैनल को सब्सक्राइब नहीं किया है तो सब्सक्राइब कर लीजिए. आवर चैनल इज लेट्स क्रैक नीट पीजी एंड प्रेस द बेल आइकन सो दैट यू विल गेट नोटिफिकेशन ऑफ एवरी क्लास एंड यू वोंट मिस अ सिंगल क्लास. ठीक है, बेल आइकन जरूर प्रेस कीजिएगा. रेगुलर मेहनत करते रहिए. यू विल डेफिनेटली एबल टू अचीव योर टारगेट विद गुड रैंक. This is the referral code Dr. Nidhi. If you want to join any paid course, you can use this to get additional 10% off. That's all for today. Thank you so much everybody for joining. See you all in the next session. Bye bye everyone.